The graph in figure 4.76 shows one complete normal breathing cycle. The cycle consists of inhaling and exhaling. It takes place every 5 seconds. Velocity of airflow is positive when we inhale and negative when we exhale. So, it's above the x-axis when we're inhaling, below the x-axis when we're exhaling. It's measured in liters per second. If y represents velocity of airflow after x seconds, find a function of the form y equals a sine bx that models airflow in normal breathing. Right, so first of all, they told us here that the model to use was sine. But even if they didn't, so if they don't tell you, you get to choose. Choose the one that's the easiest. Right? So any equation, trig equation, that is this sinusoidal curve could be sine or cosine. Right, depending, because sine is a shift of cosine and cosine is a shift of sine. Choose the one that doesn't need the phase shift. Use the one that's starting at the y-axis. So here sine would make sense because we have the point 0, 0. That way we don't have a phase shift. Right? And we can see from our graph there's no vertical shift because we're oscillating around the x-axis. Right, so we need to figure out what A and B are. So A is the amplitude. It's half the height, or half the distance, from the maximum to minimum values, or minimum to maximum values. Doesn't really make a difference. Maybe I'll put minimum first. And remember, amplitude is always positive, but if our graph is reflected, we'll include a negative. Our graph is not reflected, right? We go up first and then down. That's what the sine graph does. All right, so we are in this graph, we can see that half the distance would be the midline to the maximum. Our amplitude is 0.6. Right? Here we can see what the period is. The period is 5 seconds. But even if they didn't tell us, a graph, the sine graph, it goes up to its max, it goes back to the x-axis, it goes down to its min, back to the x-axis. And so that distance would be 5. So to B, remember to find the value of B, we want to solve the equation that makes our period true. All right, so our period is 5. Our equation number to find period is 2 pi divided by b equals the period. In this case, 2 pi divided by 2 pi divided by b equals 5. Do I have enough space to solve there? Let's see. Maybe if I move up a little, it's not the whole thing, just this. It's weird how the thing chooses to connect values sometimes. There we go. And if we move that up, there, we have a little bit of space to solve. All right, so let's multiply both sides by b to get it out of the denominator. So that would be, actually, let's parentheses. That would cancel here. So this would be 2 pi equals 5b. And then divide both sides by 5. And so that means that b is 2 pi fifths. All right, so now all we need to do, and we could check that. Let's just do a little check. All right, so to check, we just plug that back, find the period, right? We plug that back in to find the period, and we should get 5. So in other words, 2 pi divided by 2 pi fifths should equal 5. All All right, so now let's simplify that. Well, the 2 pi's will cancel. So now I have 1 over 1/5. Well, dividing by a fifth is the same as multiplying by 5. So that one did check out. And then we can write the equation. So our equation, I'll put it right here, is y equals 0.6 sine 2 pi fifths x. And there we go. And that's all there is to it. All right, thanks for watching.